So first we will go through some very technical things, how to program, where to find libraries, and this is really interesting to you only if you are going to use RuuviTags. Then we are going to have a short break, and then we are going to discuss a bit more generally on how we view distributed ledgers and what kind of features we are looking for and why we think that this ledger technology is important for us. And that must be of interest to anyone who is looking to work with blockchains on these very constrained embedded devices with very little memory and very limited power and maybe even battery operated devices.
Do I get it right? You have already IOTA on it, no?
Do I have?
You have already IOTA on your device, right?
Yep.
Yeah. But where does the wallet, IOTA wallet, come into game? Is it on there, or should I put it on the Pi?
We'll go through this in the presentation.
Okay.
Yeah. Okay, we have had the promised 5-minute break, so let us start this presentation. So, like I mentioned, we'll start with generic what is Ruuvi, what is RuuviTag, and very technical and special to this event, so mainly of interest to those people who are going to use RuuviTags in their projects during this hackathon. And then we will have a short break, and after this break we will have a bit more generic view into these embedded devices and blockchains and how do they go together or do they go together at all. So hello everyone from my side, I am Otso from Finland, working at Ruuvi. I think the CV nowadays says CIO, however we are a small group of 4 people, have been developing Ruuvi and RuuviTag for quite some time. Officially we launched in a Kickstarter a bit more than a year ago. The Kickstarter campaign is now happily completed, and we are ramping up the production and building up more massive clients and finding out new use cases for our product. So, to repeat what we already went through yesterday, what is RuuviTag? So RuuviTag is a Bluetooth sensor beacon, and it has sensors for humidity, temperature, air pressure, and acceleration. Also, something that maybe set us a bit aside in a positive way from many other open source and maker-friendly Bluetooth beacons is that we have full certifications on our device. So we have CEE, FC, and IP67, so on. So basically, you can take our product and sell it and be confident that no one is going to come ask any harsh questions about is this certified and is it actually allowed to sell a product based on these devices. So let's dive right into the deep end of the pool and talk about Bluetooth connection models. How many of you have previously developed something with Bluetooth? Maybe with iBeacons, maybe with Edison, something like that? So, no one. Okay, that's great, since we are going to really go through the basics then, so it is very useful for information for all. Basically, this is a field which is constantly evolving. So, right this summer, Bluetooth officially launched their mesh specification. How many of you basically have heard of or know about mesh networking? Yeah, so few hands come up. Okay, so this is new. But let's start with this traditional beaconing model. So we have this beacon, and as you can imagine, beacons, lighthouses, they send out and they don't really ask if it was received or who saw it. So this is known as one-to-many transmissions. You have one device, one RuuviTag, and it sends data out to many listeners. And this is where RuuviTag firmware is most mature. Today it has been shipped for something, well, has been demoed for more year and has been shipped for something like 6 months by now. So we are pretty confident that there are no big surprises if you use this broadcasting model on RuuviTag. And then we have this one-to-one model, GAT profile or generic attribute profile, which allows you to connect Bluetooth device. So this is familiar to you if you have used Bluetooth keyboards, for example. So you basically establish a connection to device, and then the connection is between your tag and your master, whatever it may be. So as of right now, in the official published firmware, we have possibility of updating the Ruuvi software using this GAT profile, but not really any kind of sensor applications yet. And for some time we have been developing also this GAT profile for sensor application, mainly for accelerometer and also for this event. So when we have this need that you have to transfer a lot of data pretty reliably to one listener, then this Bluetooth GAT with connection one-to-one is very good option. And this is how we are going to send these MAM messages on this hackathon. And a characteristic of these GAT profiles is that you don't just have to have one GAT profile which does just one thing, but you can mix and match. So you can have something like MAM, and you can have something like device information service, and they are all split down into very standard characteristics. So you can just take any Bluetooth device and ask, hey, which services do you provide? The Bluetooth device will answer, okay, here are these services with these UUIDs. And then if they are standard services, you will know what does this data mean, what I can do with it. So if you have a standard battery level service, you can just check, hey, do you have battery level service? Yes, I do. Okay, please tell me what is your battery level, and here you are. So it's great for interoperability. But of course, if you have a special case, such as this MAM messaging, there is no Bluetooth standard for it just yet. So then you can always create your own custom services, and you can always have many of these services in the same device. Finally, the new addition is this many-to-many communication model, also known as mesh. So you can, for example, sprinkle the tags all over this hall, and if there is one tag you cannot hear with your gateway or your phone, you can just ask from one node, which will... A second. Yes. So, if you cannot hear the node on the other side of the hall, you can just ask the first node, hey, how is this node doing right here? Frankly, we don't have a mesh of presentations here, so we could spread the word. Yeah, but that's the basics of the connection models, and next we will take a bit deeper look into these. First of all, we have this broadcast, and programming-wise, I think this is the simplest. We have tags, and tags send out advertisements, and then your device may hear it, or it may not hear it. If you hear it, great, you get data, you do something with data. If you don't hear it, well, so it's just life. And the simple thing about this is that you don't have to establish any connections, so you don't have to take care about is there a connection and are you registered to the right services and so on. You just start listening, you listen to what comes in, and then you check the data. Is this something that I can use? So this advertisement has MAC address of your tag, and also the way Ruuvi, for example, sends this sensor data, we have this manufacturer-specific data field. So we will just send, hey, this is manufacturer-specific data. The manufacturer is Ruuvi, and then we have the data, and you know that, okay, this is Ruuvi data, and this is how I interpret it. Well, then, on the ways you can receive data from RuuviTags, we offer you two modes. First of them is this edit zone URL, how many of you have heard of Eddystone? Yeah, so we have a few. So basically, let me ask this way, how many of you have heard of iBeacon? Yeah, a few more. So it's a bit more known protocol. So Eddystone resembles somewhat iBeacon. You have beaconing protocol. Eddystone is developed by Google, and it has this nearby service and notifications enabled. So basically any Android phone which has these services enabled can hear this URL, and it can load it and show a notification to the Android phone having customer that, hey, here is this URL, so you can advertise anything. In our case, we advertise sensor data. The beauty of this is that you don't need any special application. You just show the URL, load the data. It's a web page, JavaScript, nothing difficult about it. But then, because we are talking about building applications here, let's go to the raw mode. The raw mode is where we send the data in our own Ruby format. And then you will just have to detect, okay, this is Ruby format data, and pass it on to your application, and then your application will decide what to do with the data. And then, of course, since we have 100 beacons in our pack, there is going to be some confusion on, okay, which one of these tags is mine? So just a practical point of view, find yourself a Bluetooth beacon scanner which shows you signal strength. Take your mobile phone and place it right on top of a beacon. Then you just check, okay, this beacon is strongest signal, write down the MAC address, and now you know which beacon you are working with. And in the program, you don't just have to whitelist the MAC addresses. You can just decide that, hey, I want to listen to every Ruby beacon there is, and you will just check the data and pass it as appropriate. And this is really quick primer on the advertising model. If you want to get into in-depth details of the advertisement, packet structures, all the details of it, you should Google this BLE advertising primer. It will be one of the very first hits, and I really recommend it as a more in-depth review. So, how do you get started with this advertising model? So Ruby is very heavily invested in open source, and we have a, well, of course everything is relative, but we have a strong and active community with over 400 members on our Slack. And our community has provided many different libraries and example applications, and they are on open source on GitHub, and they are more or less officially supported. So basically we will make sure that these applications we present, we will not break them if at all possible. And also we will know how to use them and how to debug them and so on. So, how many of you like to develop in Java? Yeah, we have a few. So this is first link. I think you can find this presentation from Dropbox, and if you can't, I will just put it in Slack so you can get the links. And how many of you prefer to use Python? Yeah, we have a few more. So there is this Python library, which will also listen to the advertisements and print them out, so feel free to develop on them of it. Node.js, Node-RED users. Yeah, also a few. So we have examples on those. And just a word of caution, we actually only had Node-RED yesterday, and then someone asked, hey, how about plain Node.js without this Node-RED? And so I kind of hacked it to work with Node.js as is. So just ping me on the Slack if there is any problem, and I will look into solving them, just to give you a precaution on it. Then there are a few smartphone developers. We don't have iOS as of right now, but there is an Android application available from Centria University of Applied Sciences. So you can just download the application if you want to check it out, or you can check out the code and continue to develop on it. Also, you can see this page lab.ruuvi.com almost on every slide, and this is maybe the one slide you should remember, since it will take you to our tutorials where you can find all the information written down and a lot more than we can cover in here. So then maybe more on point of this what we have here today on distributed ledgers. GATT connection, so one-to-one connection. Basically, the way this connection process goes is that we have a beacon sending out advertisements, the same way there was in this one-to-many model, but right now we will also advertise that, hey, you can connect to me. Then the central device, which must be your smartphone or Raspberry Pi or laptop, will send a reply, hey, I would like to connect to you, and there will be negotiation of connection parameters going on. The Bluetooth tag will take care of those kind of details, so you don't have to worry about it, and the connection is established. Then you can check what services there are available and what kind of characteristics these services have. And then, for example, in our case, we have implemented something known as Nordic UART service. So how many of you have been doing embedded development, Arduino, the like? UART is familiar? Yeah, for a few of you. So this Nordic UART service is kind of emulation of UART protocol on top of Bluetooth Low Energy. So basically we have receive and transmit, which are familiar. And on transmit, well, the device will transmit data up to 20 bytes a chunk, and on receive you can send data back. So it's really similar to what would be on UART. And right now we have implemented a basic protocol on RuuviTag. So we have simple commands such as turn on temperature sensor, take one sample, or turn on the sensor, keep taking samples, what was the latest sample, and of course this please give me a MAM message. We have an example application which will go through these messages. And also, since this is alpha stage firmware, there are some rough edges, and you will have to upload a new firmware on your RuuviTag if you want to experiment with this. And more details can be found at lab.ruuvi.com/iota, and you can always ask us, also Lauri there and Andreas, on more details and help if you need it. So then there is this question, now you know how do you get data out of these devices? How do you use it? And this plain temperature, humidity and air pressure, that's quite simple. We have a ton of examples. You can find this Grafana and InfluxDB example. You can just clone it and rebuild it and customize it as you like. So no big issues there. But acceleration is somewhat tricky, because usually when people want to try out acceleration, they want to have a fast update rate. So they want to know maybe even 10 millisecond rate of what was the acceleration, was there a shock, and so on. And this broadcast model doesn't really support it, because we broadcast something like once a second, and there is very much jitter in it, so you cannot really tell a lot about the acceleration. You might even miss a hard crash on something if it is like there was a crash but it didn't fit into this 1 second measurement window and you didn't see it in the data. So we used to have a GATT profile demo which printed out this acceleration data at higher frequency, and I will look into it if I can set up a demo environment and the instructions for you today, but I cannot really promise it. And let's say you'll get a go, no go on if you're going to have accelerometer data from RuuviTag today. Also, we don't implement any kind of logging in RuuviTags. So if the connection is lost, or if you don't catch a broadcast, the data is gone, and you'll just have to sort of live with this uncertainty. It is more of an implementation detail than anything related to technical limitations. So logging can be implemented, but in the scope of this hackathon, I don't think it is feasible to implement any kind of logging into these tags. Well, this MAM process Andreas just told you, I think this deserves a more in-depth look. So, how do you use MAM? First of all, you need to update the firmware, and then you will need to build a connection with your RuuviTag. Once the connection is built, you will have to send a message to RuuviTag. Please send me an MAM message. The RuuviTag will build the message, split into these 20 byte chunks, send the chunks to your receiver, and you will have to reassemble this package. Then you have this complete MAM payload. So let's take a look at the example on how the process goes. So first of all, this is a wall of text with bad contrast, and I am sorry for it. So basically, I think this is something you have to check on the presentation afterwards. However, if we could see this slide, we will see that the tag is building a plain text message. So you have temperature, 25, humidity, 43, air pressure, 100,000 something, for example. And then we do this MAM encryption and end up with this tryte encoded message. So those are the trytes, and those trytes will be sent to the receiver, and they form up this MAM message itself. And this is another wall of text which also doesn't really make itself out of the slide. So let's just say that here we have the same thing on the receiver side. We receive the MAM message and we parse the MAM and turn it back into ASCII, and we can read out what the data was. Okay, so here we have a bit better color scheme for this presentation. This is what happens after you have published the dangle. So basically, you pick an address. We have something like 999999999 and Ruuvi 9 loves 9 IOTA. And then all these transactions are published in an IOTA transaction. There is this message field which Andreas told you about, and we will simply place the MAM message provided by RuuviTag into this message field. And then we will publish it to dangle, send it to this address, and the receiver can be anywhere in the world. It will just look up, okay, please give me all transactions which have been sent to this address. You pick up the transactions, and if you have the same seed which was used for signing the transactions, you can recraft the transaction. And actually, I think this is something that takes a lot to process, so any questions about MAM publishing at this point, or MAM publishment dangle? A picture? Excuse me, I can't quite hear you, so I'll come a bit closer.
The EAM encryption, where is done? In the sensor, in your application device?
Okay, so the encryption. This is one of the actual. Sorry about that too. This is actually one of the fine points on why we like to use MAM. The encryption is done on RuuviTag. So the gateway doesn't have to know your key. So you can just send the MAM message to any gateway. The gateway, it might have your key, it might be able to decrypt and understand the message, but it might be just something you don't trust. It will only send the message onward. So the encryption is done on the RuuviTag. And the follow-up question, where is the proof of work done? Proof of work is done on the gateway, so it might be laptop or Raspberry Pi.
IOTA full node has to be there, or how does it work? On the device I need the light node, which is correct. On the device I need the device that is connected to the Ruuvi.
Yes, so you have a gateway which is connected to Ruuvi.
Yes. There I need the full node or the light node?
The node is a light node, so we don't have the full dangle on it.
This light node then connects to the full node, where the proof of work has been will be executed.
Actually, do we have Andreas? Okay, so this is something you will really have to verify. But my understanding is that you do the proof of work on your light node, and you connect the full node and publish it there. So you do it on your own device. Okay. So, next let's go into these low power considerations. This is closely related to this foo encrypts and foo does proof of work. So basically, if you imagine a battery powered device, few tens of kilobytes of RAM, half a megabyte of flash memory, and maybe few tens of megahertz of core block. And if you are lucky, it just might have an FPU or a floating point unit in it. So basically, for our uses, the battery should last for the entire hackathon. You can do whatever you like. The battery will last for this 1 week. So that's a relief. But all activity you are doing on your project has a price in terms of energy. So as long as your tag does nothing, it is sleeping, sensors are in low power mode, we can consider this to be free, so to say. So basically, the drain on battery is very low, and since we are not using any energy or so, it doesn't really cost you anything to have the device sleeping. But as soon as you start processing some data, so maybe you read sensors or start doing this MAM message, processing data, it will wake up the CPU and it will start consuming energy. And then sending and receiving over radio is very expensive in terms of energy, so you want to minimize the bandwidth you are going to send. And of course, this very much high power consumption, it's very relative. So we are talking about milliwatts, and well, someone might say that milliwatt is not a lot of energy. But if you want to have your device running for a year or for 5 years, you have to be careful on how you use the energy you have on your device. So this concludes the technical part of the presentation, and I think we can take questions related to tech right now, if there is anything else, and then a short break, and then we can go on for a more generic view on how we at Ruuvi, or at least I see what is in, or why we are interested in these distributed ledgers. Okay, I think we do not have any questions then. Clock is right now 14:50. So let me ask this way, how many of you feel like you want to have a short break? Or should we just proceed? Okay, let's keep on going. So, from a point of view of a sensor maker, these distributed ledgers, so we have few special characteristics. So even if we have a very small installment, let's take my apartment for example. I have something like 10 RuuviTags in my home. So one outside, one on the balcony, one on the fridge, one on the freezer, one on top of my shower, few around just because. And something like 10 tags, it doesn't sound like a much, but each one of these tags will provide a transaction or send data once per second. So actually each of these tags produce 3,600 transactions per hour, or 36,000 transactions from 10 tags per hour. So if we keep this going for a year, we are talking about hundreds of millions of data points, assuming that I did not miss carry at 0 somewhere. But anyway, the volume is huge, even for a very small installation. So what is an acceptable cost for this kind of transaction? How much we can pay per sample if you're going to have hundreds of millions of these events? Well, this price can be in energy, or it can be in gas, it can be in money, but I think we can all agree that any kind of fee pretty much kills any business model. We just cannot pay 1 cent per transaction. We cannot even pay 1/100th of a cent per transaction because the volume is so huge. So, of course, we can then decide that, okay, this is uninteresting data. No one needs to know what happened on my balcony last June at some point of the in let's say with 1 second granularity. Well, yes, it's true. No one needs to know that. It's sort of noise and meaningless data for everyone. So why we just aren't going to be smart with what we store? So why don't we just collect daily report, okay, no accident today, and send that report? Well, the first thing is that what is an accident? how do we program this is an accident and now we need to know with better granularity, we need to know more precisely what exactly happened. Since we are programmers, we just cannot anticipate all the events. So now here we have a ship with a lot of containers, and right now what has happened here? Okay, so if you think of aggregate data, I am pretty sure that we will see huge spikes in accelerometer. There has been some tilting. So basically this aggregate once per day data, it can tell us that okay, here has been an accident. Well, I think we all knew it just by looking at the picture. And then this is where this trust and reliability in data really comes in. Let us imagine that few of these containers have packages with second by second verified data coming out. You can only imagine how much it will make life easier for everyone. So, right now we have the situation that we used to think that this data second by second was worthless. But now we know there has been an accident and suddenly that data is very expensive. We want to know what happened. And of course no one wants to take this responsibility on, okay, our bad, it was our container, we were kind of skimping on the quality of screws. And the insurance company, like always, they want to know exactly what happened. And I think this is the reason why we want to have this ledger on events at very high precision, at very high granularity. So this is my personal view on what does this mean for the embedded. Why do we want these distributed ledgers and where it is useful and what kind of characteristics there are. So energy is expensive. We, as of right now, cannot really do proof of work on these devices because doing proof of work, well, it is work, work takes energy, and we have this one tiny battery, and even if the battery is cheap, having someone take care that the battery will not run out during the next trip and replace it, that's not cheap. Well, bandwidth is also expensive, like we talked about. Every transmission is in the battery, bandwidth is energy, and it is expensive. Memory, we have something like 40 kilobytes available for this MAN encryption. And this is another thing I really had to thank Andreas for squeezing it into small area. And also, if there are any kind of transaction fees, because of the volume of transaction, any kind of fee on this transaction is also very expensive. And like we also had this idea that we don't really have to know, or we don't really have to keep this set in stone eternal record of what happened. It is enough that if we have a container crashing inside a ship, we can check, okay, this happened a week ago, let's store all the data and process it later. But we don't really have to know what happened on a shipping container where nothing exciting happened 5 years ago, not second by second. So, any technology which we use, first of all, it must have wide adoption, because we could probably make Ruuvi Ledger and say, hey, this is the best thing ever, and try to market it. But if no one has ever heard of it, no one is really interested in court using it as evidence of anything. And also, this technology must scale with the volume of transactions. So, right now, we were talking about hundreds of millions of transactions from 10 tags. So what if there is 10,000 or 1 million tags sending data at the same rate? So I think this can all give a sense of scale for all of us on what we can expect on these IoT distributed ledgers. So these are my ideas on how it might look like on embedded devices and also why we are interested in being here. So thank you for your interest and attention. And I think we can now have a short round of discussions, questions if you are interested, or then we can get back into the hacking and building awesome demos. Thanks.